Thank you, yes. This is. In this presentation, summarized the main result obtained by an experimental on the structural response of a FRCM partially confined masonry column. In particular, we study clay, small size, clay brick masonry column, confined, partially confined. Column confinement with FRCM is a well-established reinforcement technique that provides a significant increase of strength and deformation capacity. Masonry columns are usually confined with fiber-reinforced composite jackets along their entire edge. This is the full wrapped column, or the continuous confinement. Alternatively, they can be wrapped with longitudinal discrete jackets, and in this case we have the partially wrapped column. Partial confinement represents an optimal design solution in masonry columns that require a limited increase of strength and deformation, but also in historical construction where the breakability of masonry is needed. The effectiveness of fully confined masonry column has been the subject of many studies and research conducted on column under both concentric and eccentric load, varying geometric and mechanical parameters such as the amount of reinforcement, the mortar grade, the column geometry, the load eccentricity values. Limited information are available on the structural response of partially FRCM-confined masonry column. At the same time, no provision are given in the main guideline and code. In this context, the analysis of the mechanical response of masonry column partially confined with FRCM is of particular interest. 4 series of experimental tests were carried out on clay brick masonry column in order to investigate the effectiveness of the partial confinement. And in this case, parameters variable were the amount of the textile, equal to the number of confining layers, the second experimental investigation we consider as the same masonry column made with the same unit, clay brick unit, and in this case we consider as variable parameter the type of composites. In particular, we consider the basalt FRCM and the steel FRCM, with also the number, the confining layer variable between 1 and 3. Also in this case, the vertical spacing ratio was kept constant, equal to 0.5, and 7 columns were tested, 1 unconfined, 3 partially confined with basalt FRCM, and 3 partially confined with steel FRCM or SRG. The mechanical properties of materials were determined by standard tests. This is the results in terms of stress, strain, curves. On the left, the basalt FRCM-confined column, and on the right, the steel FRCM-confined columns. The curve are the similar trend for both confining configuration, confining material. The table reports the value in terms of confinement ratio, ultimate strain, elastic modulus, and the ductility index evaluated by the ratio between the area under the stress in terms of energy index. Well, this is a diagram that reports the variation of the confinement ratio with the axial rigidity of the jacket, the confining jacket. It appears that increasing the axial rigidities of the jacket, the confinement ratio decreased. Failure mode was different for varying the number of confining layer. In particular, for 1 and 2 confining layer, the failure was due to the attachment of the textile in the overlap regions, while for 3-layer confined columns, the failure was due to the crushing of the masonry in the unconfined region after the formation of many vertical cracks. No detachment took place in the confining strips. The same results were obtained for the steel FRCM-confined column, similar. And the main result of this second series of investigation was that increasing the rigidity of the FRCM system, increasing the number of confining layers, the strength of confined masonry decreases, while the ultimate strain increases. This unexpected result depends on the high vertical spacing ratio value, which was considered in this investigation. For this reason, in the third series of experimental investigation, the main parameter considered was the vertical spacing ratio. In this investigation, the PBO-FRCM composite was used as confining material. The geometric configuration, the vertical spacing ratio varies between some values that are reported in 0 corresponded, the value 0 corresponds to fully confined column, and the other value is variable with the number of confining strips considered. In this case, we used only 1 layer for each strip, one layer of textile for each strip. Same procedure, the determination of mechanical properties of material, the test setup, the measurement devices used. In this case, we measure the horizontal displacement in correspondence of the strips, the composite strip, and in correspondence of the masonry in the unconfined zone. Regarding the failure mode, we have the traditional failure for unconfined column and for fully confined column, and in the case of partially confined columns, the main result obtained is that the higher the number of FRCM jackets, this means the lower vertical spacing ratio, the more the failure were dominated by the corner effect. The table reported peak load, strain, and ductility, and also the elastic modulus. This is the variation of the confinement ratio with the vertical spacing ratio. Increasing the vertical spacing ratio, the confinement results decreases. The axial stress strain curves for unconfined column, fully confined columns, and partially confined column, varying the vertical spacing ratio. This is the total axial stress, axial strain curves for the partially confined columns. And also, it is interesting, this diagram that reports the variation of the ratio between the stiffness measured by the elastic modulus, the stiffness of the partially confined column, and the stiffness of the unconfined column, or fully confined columns. It is possible to see that increasing the vertical spacing ratio decreases this ratio. In figure are reported the lateral displacement measured by the LVDT, both in confined zone and in unconfined one. This is the relationship between the strain, the lateral strain, the upstrain, and the axial strain. And this is the evaluation of the exploitation ratio for all confined configuration. The ultimate experimental investigation was carried out considering as variable parameter the vertical spacing ratio, but differently to the previous investigation in this series, the amount of textile was kept constant. The configuration obtained was described in the column. In the table, the test setup, similarly to the previous setup, the failure mode generally depends on the vertical spacing ratio. It was similar to this that's described in the previous investigation. It is interesting to note the damage pattern for the confined cross-section of the column, and increasing the number of confining strips that is reducing the vertical spacing ratio, it is possible to note the formation of the typical parabolas that describe the presence, the activation of the arching-like effect, typically of the confined columns. This aspect needs more investigation because there are only few results. Deeper investigation is needed. Regarding the analytical investigation, we consider the two models, in particular the model of the Italian guideline and the American Concrete Institute guideline, taking into account that this model refers to fully confined columns. To take into account these are the relationships that describe both models, in particular in the Italian guideline, are present two coefficients that generally were set equal to 1 if experimental results are not available to justify different assumptions. Well, to take into account the partial confinement, the relationship were modified by considering the vertical coefficient of efficiency provided by another Italian guideline that refer the concrete column confined with FRP jackets. In this case, the new equation were reported in the slide, and the table report the obtained result with the obtained prediction of both models with reference and also the experimental results. It is possible to see that code predictions are conservative. The Italian GAD model was modified by an accurate estimation of the two coefficients alpha 2 and alpha 3 for the clay brick masonry with used in this experimentation by available results found in the literature. It was possible to determine these two values of the coefficient alpha 2, 3.5 and alpha 3, 4.6, and the new prediction are reported in the table, but in this case, the new predictions are unconservative. By experimental results, it is evident that the stiffness of the confined columns varies as the geometrical configuration of the partial confinement changes. Accordingly, a new parameter was introduced to modify the expression of the effective lateral pressure of the confined column. This new coefficient was reported in the last of the slide. It is related to the ratio between the stiffness of confined and column and that of the unconfined one. The parameter was, the coefficient gamma was estimated by using the experimental result and then by other analytical consideration at the new prediction by obtained by using this model, this new model, are in good agreement with the experimental results. It is evident that the limited number of experimental results doesn't allow to generalize this result. More results, more experimental results are needed to verify the effectiveness of the proposed model. Okay, thank you.